Alright, Chapter 6, Section 6.1, we're talking about the Polygon angle sum theorem. As we start off this class, I had you guys do a little investigation where we take any number-sided polygon. So in this case, I asked you to take a polygon with 4, 5, 6, and 8 sides, create this table, name the polygon, the number of sides, and then within the polygon, inside, how many triangles can be formed? All right. If you did that investigation, you would find out that the number of triangles formed inside each of the polygons is 2 less than the number of sides, which is where we get the formula for the polygon angle sum theorem. The sum of the measures of the angles of an n-gon, that's any number-sided polygon, is n minus 2 times 180. So the number of sides, subtract 2 times 180. Find the sum of the measure of the angles of a 15-gon. So in this case, we're going to take the number of sides and substitute in 15 to our n minus 2 times 180 formula. So 15 minus 2 gives us 13, and 13 times 180 is 2,340. So the sum of the measure of the interior angles of a 15-gon is 2,340 degrees. Next, the sum of the measure of the angles of a polygon is 720. What type of polygon is it? Well, let's see how we do this. Here we're going to use n minus 2 times 180 equals the sum of the measure of the angles, 720. In this case, we're solving for n, or the number of sides, to figure out what type of polygon it is. So we start by dividing both sides by 180 degrees. This gives us n minus 2 equals 4. So we get n equals 6. So we know this is a hexagon. When we talk about regular polygons, the word regular in the context of these geometric shapes, these polygons, just means that all the sides are congruent and all the angles are congruent. So a regular polygon is a polygon with both equilateral, that is both equilateral, meaning all the sides are congruent, and equiangular, all the angles are congruent. So the question is, what is the measure of one interior angle of a regular hexagon? Well, we know all 6 angles are going to be the same measure. That's what equiangular means. All right. Since it's regular, we know it's both equiangular and equilateral. So we're going to use n minus 2 times 180 again. So it's a hexagon. 6 minus 2 times 180 gives us 4 times 180. So we know that all the angles added up equals 720. The question, though, is what's the measure of one interior angle? So what do you think we're going to do? We're going to take 720, divide it by 6, the number of angles for a regular hexagon, and find out that one angle of a regular hexagon is 120 degrees. Let's use the polygon angle sum theorem to find some missing angle measures. Here, number 1, what is the measure of angle y in pentagon TODAY? So we have all these angle measures. We know it's a pentagon. It has 5 sides. So we're going to use 5 minus 2 times 180, which is 3 times 180, which is 540. So we know that all the angles inside that pentagon have to add up to 540. So I'm going to take all 4 angles that I know, plus the measure of angle y, add those together to equal 540. When I combine like terms, I get 470 plus the measure of angle y is 540. So I just have to subtract 470 from both sides to find that the measure of angle y is 70 degrees. Number 2, What's the measure of angle G in quadrilateral EFGH? Well, what's the sum of the interior angles of a quadrilateral? 4 minus 2 times 180, so 360. All right, then we do the same thing. We add up all the angle measures to equal 360, including the missing angle measure, measure of angle G. All right, isolate the measure of angle G and we get 102 degrees. All right, let's draw all the exterior angles on this pentagon. So you can pause the video and do that if you want, or you can watch what this looks like. We're just going to extend one side of every vertex on the exterior of this pentagon. So here we have 5 exterior angles. It says make a conjecture about the sum of those 5 angles, or the sum of the exterior angles of any sided polygon. Well, if I look at this, it looks like if I were to kind of add angle 1, 2, 3, 4, and 5, that it creates a full circle. So it's true that the sum of the exterior angles of any sided polygon, not just this pentagon, but any sided polygon, will equal 360 degrees. So now the question is, what's the measure of one exterior angle of a regular pentagon? Well, for that, we're just going to take 360 divided by 5, which is 72. So if we look at that pentagon and say that that's a regular pentagon, measure of angle 1, 2, 3, 4, or 5 would be 72 degrees. All right, so let's go over everything we've talked about. What's the sum of the interior angle measures of an 11-gon? So again, we're going to use our n minus 2 times 180 here. N minus 2 times 180, or 11 minus 2 times 180, gives us 1,620. What is the sum of the measures of the exterior angles of a 15-gon? Remember, exterior angles add up to 360. So in this case, we're going to go 360. What is the sum of the measures of the exterior angles of a 15-gon? It doesn't say anything about regular. So this would be, 360. Easy. All right, and then find the measures of an interior and an exterior angle of a regular decagon. So in order to do this, 10 minus 2 times 180, all right, and 360 divided by 10 for the exterior angle. So an interior angle ends up being 144. An exterior angle ends up being 36. That's it for lesson 6.1. Your homework is on mathexcelforschool.com, due Sunday at midnight.